Hi, welcome back. In the last video, we got Splunk running on micro Kubernetes and onboarded the first basic log. Today we go deeper. I'm going to add FluentBit as a daemon set to collect every major log sources in the clusters. The pod logs, Kubernetes events, all routed to separate indexes with proper source types. And now I'm going to show you how to query and analyze all of that data using plain English. No Splunk language, just asking questions and getting a structured report back. Let's go. Before we jump into the demo, let me show you the architecture we are building today. Every Kubernetes cluster has a multiple log streams that you actually care about. Post standard out stream, standard error stream, and that's your application logs. System journals for Kubernetes, and then Kubernetes events, which are completely separate from container logs, and honestly, the most underrated data source in any cluster. The reason I am using FluentBit rather than just telling files directly is a scale. FluentBit runs as a daemon set, one pod per node, so it automatically handles a new node as the cluster grows. It handles log rotation. It has a persistent position database, so it doesn't resend events after a restart. And it enriches every log like with Kubernetes metadata, namespace, pod name, container name, as a structured field you can search on directly. Each log source gets its own index. Pod logs goes to Kubernetes_pods. System components go to Kubernetes_system. Events go to Kubernetes_events. This means in Splunk, you can scope searches to exactly the data you need rather than filtering one giant noisy index. Let me extend the existing setup by running a prompt to add FluentBit and onboarding the new logs. So there are again 4 phases in this prompt to run. Each phase requires confirmation to move to the next phase. OpenClaw runs super slowly and crashed several times. It's adding the FluentBit ham repo, writing the values files, installing the daemon set, and look at the values file it generated, separate outputs block per log source, each with the correct index and token. Each source tag with a source type before it even hits Splunk. FluentBit pods are running, one per node as expected. And let me tell the logs to confirm it's reaching heck successfully. And here we go. Data flow into all 3 indexes. Kubernetes_pod has many application containers logs with full Kubernetes metadata. k8s_system has Kubernetes. k8s_event has every scheduling decision and state changes Kubernetes has made in the last few minutes. One thing worth calling out separately is the Kubernetes events folder. Events don't come through container logs. They come through the Kubernetes API directly. So I have a small Python script running as a systemd service that watches the events API with kubectl and streams each one to heck in real time. Why does that matter from security perspective? Kubernetes events capture failed authentication attempts to the API server. Pods being evicted due to resource pressure, image being pulled from unexpected registries, service account permission errors. these are exactly the low-level signals that gets missed when you are only looking at application logs. After the Kubernetes log onboarding, we can see 3 indexes, k8s underscore events, pod system. We can send a prompt that to browse Splunk pages that to search errors. It doesn't directly read from the browser, but rather requesting via HTTP API. Okay, loading.
No Splunk query language required. Just type in plain English to generate a report through Kubernetes underscore pod index. The search targeted error and warning keywords across all namespaces, and over 7,500 events spread across namespaces like Kubernetes system, open projects, Fluent bit loggings, Istio, and HashiCorp Vault. Most of the errors flagged were actually Fluent bit internal filter warnings, not real application errors. It's a non-benign behavior where the Kubernetes filters tries to match container log tags against systemd and journal log, and which don't follow the same format. The AI correctly identified this and filtered them out of the real findings. The report even gives you a Splunk query filter to suppress the Fluent bit noise going forward. This is what AI-assisted log triage look like in real Kubernetes environment.
Okay, so let me pull back and talk about where I think this is all heading, because I think the implications are bigger than just Splunk, but easier to set up. What we've built across these 2 videos is a workflow where a single engineer using plain English prompts can install the production-grade observability stack, onboard multiple structured log sources, and run analytical queries across all of them. That's work that traditionally requires multiple people with overlapping specializations. But here's what I keep thinking about. Each phase of this workflow maps actually to a distinct group. The installation phase is infrastructure work. The log onboarding phase is the log engineering work. The dashboard and analysis phase is analyst work. Right now, those are all phases in one skill driven by one person. What if each phase was its own dedicated agent? An installer agent that only knows how to deploy Splunk, a log onboarding agent that only knows how to route data sources, a dashboard agent that build visualization from a schema, and an analysis agent whose only job is to read the data and write reports. Each agent picks up where the last one left off through the shared state file. They are independently runnable, independently testable. If you add a new cluster, you run the installer and onboarder for that cluster. The analyst is already watching. That's basically a small SOC team. 4 specialized agents, each doing one job well, and I'm handing off to the next. And the human in the loop is doing things humans are actually good at, reading the analyst report and decide what matters. I haven't built all 4 agents yet, but everything we've done in these 2 videos proves that the pattern works. The state file handoff works. The structured data pipeline works. The prompt-driven analysis works. Extending this into a proper multi-agent pipeline is the natural next step. And that's what I will be building in the next video. If you want to follow along, subscribe and I will see you there. And all the code from the video is linked in the description below.